Hi, this is Joyce McGill in Lab 9, which is about springs and oscillating motion. So first, the problem in this lab is to examine the motion of a spring mass system in which the mass swings in an arc while oscillating on the spring. So the physics principles used in this lab were the energy principle, which is the change in energy is equal to work, and the subsequent principles, delta K plus delta U equals work. Kinetic energy is equal to 1/2 mass times velocity squared. The gravitational potential energy is the change in mass times gravity times y, and the change in spring potential energy is 1/2 times ks times the stretch of the spring squared. And then in addition, we used the momentum principle from previous in the year, which is just to update the velocity and the position, which is final velocity is equal to initial velocity plus the net force times the change in time over mass, and the final position is equal to the initial position plus the final velocity times the change in time. So the first thing I did, of course, was I opened Tracker, and I went ahead and I set my origin at this fixed attachment point, and I set the calibration stick to 0.7 meters because that was what was given. I also set the mass of the object to 0.402 kilograms. So I went ahead and I tracked the mass swinging on the spring, and I took this data and I saved it in Excel, and then I used this VPython code to go ahead and predict the position of the mass. So the important parts of this are to find the potential energy due to gravity and the kinetic energy, as well as the potential spring. And then down here we go through and we find the change in kinetic and the change in potential due to gravity and the change in potential energy from the spring. So I went ahead and ran it. And so the red line is the predicted data from VPython. The green line is the tracker data. The orange line up here is the work, which should be equal to 0 because there's no work done by the surroundings. So I went ahead and looked at the period of oscillation. Again, the red line is the predicted data. So for X, it was about 1.7 for predicted and 2.1 according to tracker. And then for Y, the predicted was about 1.5 and the tracker was about 2 seconds. So that's a difference of about 0.2 seconds for the predicted and 0.1 seconds for the tracker data. And the reasons for this could be that simply that this is not an ideal system. It's not perfect. So there could be a few differences there, and in addition, we didn't really take into account any air resistance, so that could be a factor. So the work done by the surroundings in this is 0, which is the orange line, as you can see here. So basically that satisfies the energy principle because the system included the mass, the earth, and the spring. Therefore, the 3 types of energy were gravitational potential, spring potential, and kinetic. So all the work was internal, so there should really be no work from the surroundings. So next is looking at changing the origin of the spring. So the top one is the original data, and the bottom one is the changed origin, which is where the mass is the origin. So basically the physics of the system stays the same, but the total energy of the system, or this is because the total energy of the system is still equal to 0. But as you can see, some of the values varied, but still the sum is 0. The end.